In my last video, when we were using a U-substitution to evaluate an integral, everything turned out really nice and clean and everything was there and we got to cancel everything out. Well, what do you do if everything doesn't cancel out? At the end of this lesson, you'll still be able to use a U-substitution to evaluate an integral, but we'll just have a few tricks that we'll have to use in between. All right, we're going to go ahead and jump right into the examples, and basically what's going to be happening, we'll be missing some information and I'll show you how to get that information in so that we can still do a U-substitution. All right, so we're going to evaluate this integral, the integral of x times the quantity x squared plus 1 squared. This is going to be a perfect setup for a U-substitution because I have some parentheses. So again, just like what we were doing previously, we're going to let u equal x squared plus 1. And now I'm going to take the derivative. I will get the derivative of x squared is 2x dx because the derivative of 1 was 0. Okay, now let's go ahead. I'm going to try to start writing this and let's just see where it gets us. Okay, we know that the x squared plus 1 was u. Okay, it's raised to the second power, so I'll cross that out, put my second power down here. Now you'll notice that I have x dx, so I'd like to replace that with du, but notice that this says 2x dx, so I can't call it du because we're missing a 2. So I'm going to do a little trick here. I'm just going to put a 2 there. Okay, now notice that it does say 2x dx. Well, am I really allowed to do that? Absolutely not. Okay, if I put a 2 in there, I really have to make sure that I didn't affect the value of the problem. So if I put a 1/2 out front, notice that 1/2 times 2 was really 1, and I really did not affect the value of the problem. Okay, so what I'm going to do now, I have this 2x and the dx. 2x and dx together make du, but now I have this 1/2 sitting out front. Okay, I'm now ready to evaluate my integral. So I'm going to have 1/2. The integral of u to the second, is 1/3 u to the third. If I multiply my fractions together, I'll get 1/6 u to the third. And then from here, I just need to plug my u back in. So I'm going to have 1/6 x squared plus 1 to the third plus c. All right, let's do another one to see if that made any sense at all. Okay, so next problem. Again, we've got parentheses raised to a 4th power, so this is a perfect setup for a u substitution. So I'm going to let u be what's inside the parentheses. Okay, now we're going to take the derivative. If I take the derivative of u, I get du. The derivative of 2x squared will be 4x. The derivative of 5 is 0. And then I will put dx to show that I'm taking the derivative with respect to x. Okay, from here, let's just go ahead and start substituting things in here. I can cross off my 2x squared plus 5 because I'm going to call that u. This 4th power, I'll cross off and bring it down to my problem. Now notice I have 3x dx, and I'm supposed to have 4x dx. So how could I make this 3 say 4 instead? And if you remember from when we were working on some sign limits and things like that, if I multiplied this by 4/3, it will now say 4, because 4/3 times 3 is 4. So if I multiply that by 4/3 on the inside, this will now say 4. But if I multiplied by 4/3 on the inside, I need to multiply by 3/4 on the outside to undo it. So now from here, if I look at what I have, I now have 4x dx inside, so I can cross off the 4x dx and I can call it du. And then sitting out front, I still have the 3/4. Okay, now we're just going to take the integral. I'm going to bring my 3/4 down. U to the 4th is the integral of that would be 1/5 u to the 5th. And then if I multiply my fractions, I'll get 3/20 u to the 5th. And then let's just sub our u back in. My u was 2x squared plus 5 to the 5th plus c. Okay, I think we'll do another one of those just to see if that made any sense at all. And you might want to try this one. Let me get you started on this, and then you might want to try this one on your own and press pause and then come back and see if you got it right or not, but I'll leave that up to you. First thing that we want to do, we do not want the square root in our problem, so I'm going to rewrite this as 5x times x squared plus 3 to the 1/2 power dx. Okay, now this is a form that we're familiar with. We're going to take what's inside of the parentheses and let that be our u. So we'll get u equals x squared plus 3. Then if I take the derivative of x squared would be 2x. The derivative of 3 is nothing, and then we will put dx with it. And now let's just start substituting things in. I know I can replace that x squared plus 3 with u. I still have that 1/2 power, which I'll bring down. And then my problem says 5x dx. I really would like it to say 2x dx. So if I multiply by 2/5, that will now say 2. So if I did 2/5 on the inside, I need to do 5/2 on the outside. So now if I look on the inside, I have 2x dx, which I can cross off and replace with du. And then I have the 5/2 tagging along on the outside. I'm now ready to take the integral, so I'm going to have 5/2. The integral of u to the 3/2, if I increase the power by 1, it will be u to the 3/2 times 2/3 on the outside. If I go to multiply those together, the 2's are going to cancel, so I'm just going to end up getting 5/3 u to the 3/2, and then I'll get 5/3 with my u. Let's just sub that back in. I'll get x squared plus 3 to the 3/2, and then plus c. So that would be my integral. All right, let's try one more problem here. See if we can get this to work okay. On this one, you'll notice I have dy dx equals x minus 4 over the square root of x squared minus 8x plus 1. Okay, to solve a derivative, we're basically just going to take the integral of both sides. Okay, so on this problem, I am going to actually rewrite the right side of it before I take the integral. If I rewrote this, it's going to be x minus 4 times x squared minus 8x plus 1, and this would be raised to the negative 1/2 power because I have square root on the bottom, so if I brought it up top, it would be that. And I'm also going to put dx over here because we are taking this with respect to x. So that's what we have so far. Now from here, you'll notice I do have 2 sets of parentheses, so which one do you let be u? The one that has the power. So we're going to let u equal x squared minus 8x plus 1. Okay, and now just like we always do, we're just going to take the derivative. The derivative of u is du. The derivative of x squared is 2x minus the derivative of 8x is 8, and the derivative of 1 is just 0, and then we will put dx. Okay, so let's go to my problem and start substituting things in. I can cross off the x squared minus 8x plus 1 because we're going to call that u, and then I have to a negative 1/2 power. And then notice I have x minus 4 dx. I'm supposed to have 2x minus 8 dx. I do notice that if I would multiply this by a 2, that would give me 2x minus 8. So I'm going to multiply by 2 on the inside, which means to undo it, I will multiply by 1/2 on the outside. So now the 2x minus 4 and the dx combine together to make du, and I have my 1/2 hanging on the outside. So from here, I'm going to have 1/2. The integral of u to the negative 1/2, if I add 1 to it, it will be u to the 1/2, and then the reciprocal up front will be 2. 1/2 times 2 is 1, so I'll just be left with u to the 1/2. If I rewrite that, I'm actually going to rewrite it as a square root, and then my u was x squared minus 8x plus 1, and then of course we're going to remember our plus c. And there we have it. So hopefully now you can use a few little tricks up your sleeve to find the integral using a U substitution.